Okay, so today we're going to do two sample t-tests on SPSS, but we're going to actually do a different data set than we usually use, just for fun. We found this data set on earthquakes, and basically documents all the earthquakes that have happened over the last 100 years. And you can see that the variables are date, year, the time of the earthquake, what city it occurred in, the country, the fatalities, and then the magnitude. And we'll get on to these variables later, but let's look at the data. Okay, so here we have the data view, and like I said, there's the different variables of date, year, time, and so forth. And here we have the fatalities. And just a quick note, we have two ways of talking about fatalities. One is the actual number, and we also have calculated the natural log of that number, just as a different way of showing the differences and the numbers of deaths that occurred because of a earthquake. And here the M stands for magnitude, an 8-point magnitude as opposed to like a 7.8. Okay, so let's say we want to test a null hypothesis about whether or not there's a difference between a 7.0 earthquakes that occurred above 7.0 and earthquakes that occurred below 7.0. Okay, so now we know what our questions are. How do we actually find that out? We go to Analyze, and we go to Compare Means, and now we're going to do an independent sample t-test. And our test variable is going to be the logarithm of the natural log of fatalities. And so we just put into the test variable, and then the grouping variable is what groups are we going to compare at. And I've actually coded a dummy variable that tells me that splits all the earthquakes that were above and below 7.0. And anytime you have a grouping variable, it's going to ask you to actually define what those two groups are, because you might actually have a variable that has more than two groups. And the t-test is only for two groups. And so it's 0 for earthquakes that are below 7.0 and 1 for earthquakes that are above 7.0. So click on Continue, and then I just press OK. So it's similar to other t-tests that you do on SPSS. It gives you two boxes in the output. One just gives you the reviews, the descriptives of how many earthquakes there were below 7.0, which is 25, and the magnitude, those that were above 7.0 were 56. And it gives me the mean difference in fatalities in terms of natural log. So one of them is 4.8 and 7.1. And the null hypothesis is that they're equal. And that the differences between these two numbers really are caused by the standardized error in the different samples. The second box actually gives you that test of significance, and you'll see this Levene's test for equality of variance. For this class we don't need to know this, so we're just going to ignore this number, and what we really need to know is just on the second portion of this box. And you can see it says here t-test for equality of means. So the null hypothesis is this question of that these two means are the same. Gives us a t statistic for that assumption, and it actually gives us the level of significance. So this is saying that the probability that these two samples are the same are actually very, very small. They're below a 0.01%, meaning that there's less than a 1% chance that these are actually the same. So we would say that the difference between earthquakes that are below 7.0 and the earthquakes that are above 7.0, that difference is greater above and beyond the difference we would expect from our sampling error. So another way to say it is that it's statistically significant. Okay, so let's try another example of sample t-test, but using the GSS, since that might be a more familiar variable. And let's look at this age kid born question about how old were you when your first child was born. And looking at how it was coded, I already see that I've already excluded the missing value, so I don't have to worry about that. So just to analyze that, I just go to compare means like last time, go to independent sample t-test, click on that, and you can see that I've already moved over age kid born into the test variable, and then grouping, I had sex. And like last time, you have to define the actual groups. Sex, of course, is only 2 sexes, but if we were comparing race, for instance, we'd have to put 1, 2 for whites and blacks, or 2 and 3 for blacks and others. So you have to define the groups because, again, the t-test is only good for comparing 2 groups. Click on Continue and simply click on OK. Now let's reading this 2 boxes again. We have our 2 means for males and females, so we can see that males are already older than most women when they have their first kid. They're almost 26 and women are around 23, so there's a difference of 3 years. So looking at the second box here, we see that the mean difference is 2.843, so it gives it to you right here. And the null hypothesis is that this difference is explained mostly by the standard error, that it's not large enough. And the boxes also gives you a t-statistics for the likelihood that that's true. And taking into account the standard error of both samples, we'll see that it's actually a very unlikely thing to have occurred. That at a 0.000 level is the likelihood of the null hypothesis being true. And since that's below what is standard practice for us, which is 0.01 or 0.001, we can reject the null hypothesis. So that these 2 ages are actually statistically different. So the neat thing about SPSS is that we don't have to worry about looking up at a t distribution, what the cutoff value for t is, because it actually calculates that for us. It gives you the t statistic. It tells you at the degrees of freedom which distribution is looking at, but you don't even have to really look at that. You just have to see that it's significant at this level. If it was something like 0.5, we know that that's too high of a likelihood and that we couldn't reject the null hypothesis. So again, it's statistically different.